The best way to learn chemistry is to do chemistry practice questions. Here are 10 questions on organic chemistry. Feel free to try it out on your own first. This question focuses on functional groups, specifically on ketone. We're given 5 options and we're asked to identify ketone from one of the 5. Now, ketone is an organic compound that contains a carbonyl group, which is C double bond O. And to the left and right of the carbonyl group, there should be carbons. So looking at the options that we have, the only options that fit this requirement is B. This next question is asking us to identify alcohol. Alcohol is an organic compound that has a functional group called hydroxyl, which is OH. So basically, we're looking for a compound that contains OH. The option that fits this criteria will be A. E is not the option because E is a carboxylic acid because it has an additional C double bond O attached to the OH. For it to be an alcohol, the functional group has to be just OH. This next question is asking us to identify ester. Now, ester contains C double bond OO and that O is connected to a C. So therefore, looking at the 5 options that we have, the only one that fits that criteria is D. E is not an option because it's C double bond OO and that O is connected to H. That is a carboxylic acid. We're looking for ester where that COO, that second O, is connected to another carbon or an alkyl group, which is R. This next question is asking us to identify alkyne. Now, alkyne is one of the 3 hydrocarbons. We have alkane, alkene, and alkyne. Alkyne is the one that has triple bond. So we're looking for a functional group that has a triple bond, and the only one that fits that criteria would be option C. Option A is an alkene, option B is an alkane. This next question is asking to identify amine. The functional group for amine contains nitrogen and 3 single bonds. One of the bonds connected to nitrogen has to be a carbon. The other 2 bonds can be hydrogens or carbon. So basically, we're looking for a structure that contains nitrogen with at least 1 carbon. The only structure that fits that criteria is C. B is not the answer because the nitrogen is triple bonded to a carbon. We're looking for 3 single bonds. D is not the answer because it has a carbonyl group, which is C double bond O connected to that carbon. In fact, D is an amide, and that's not what we're looking for. This next question is an IUPAC nomenclature where we're asked to name the given compound. The first thing to do before naming any compound is to first figure out the type of compound that we're naming. Aside from bromine that is attached, there's no other functional group present. All the carbons are single bonded, and that makes this an alkane with a halogen attached to it. So we call this an alkyl halide. To name any compound, we need to first find the longest chain. There are 5 carbons that are connected, and there are 2 ways for us to number the chain. We can number it counting from the left, and then the other way is counting from the right. Aside from bromine, there's another substituent right here, which is a CH3. Now, substituent is just a fancy name to refer to the group that's attached to the main compound. So our main compound has 5 carbon, and then we have 2 substituents, bromine and CH3. So to name that CH3, we need to know this table of prefix. CH3 contains only 1 carbon, so the prefix for 1 is METH. We're going to name it as an alkyl, which means it's going to end with YL. So we just attach YL to the prefix, so it'll become methyl group. When numbering the chain, you want to start from the end that is nearest to the substituent. If we number from the left, we're going to get 1 bromo and 3 methyl. However, if we number from the right, we're going to get 5 bromo and 3 methyl. The rule is to go with a group that has the lowest set of number. So therefore, 1 bromo 3 methyl is a lower set compared to 5 bromo 3 methyl. Since the longest chain is 5, the prefix for 5 is PENT, and then because this is an alkane, we add in the suffix ane, so then the parent name is going to be PENT-ANE, that's pentane. So the final name is 1-bromo-3-methylpentane. This next question gives us the structure drawn in bond line. We start by figuring out the longest chain, and that contains 8 carbons, and it comes with 2 substituents. This group with 1 carbon right here is a methyl group, and then this group at the bottom here, which has 2 carbon, the prefix for 2 is ETH, and since this is an alkyl group, so we're going to attach YL to it, so it's going to be ethyl. Numbering from the left is going to give us 4 ethyl, 5 methyl. And if we number from the right, it's going to give us 5 ethyl and 4 methyl. Now the rule is to go with the lowest set of numbering. In this case, we're working with 4 and 5. Since we need to alphabetize our substituent, ethyl comes before methyl. Reason being, E comes before M. And for that reason, we're going to prioritize ethyl first over M. And therefore, we're going to go with the 4 ethyl, 5 methyl as part of our final answer. Prefix for 8 is OCT. And since this is an alkane, we're going to add in ANE, so that becomes octane. Final answer is 4 ethyl, 5 methyl octane. This is another question on naming the alkane. The longest chain contains 7 carbons and it has 3 substituents. And all the 3 substituents are the same and they all contain 1 carbon, so that makes them methyl group. And if we number from the right, it's going to give us this combination which is 3, 3, 4. And that's the location for the methyl groups. Because we have 2 groups attached to carbon 3, we need to write out 3 2 times. So we can't just say 3, 4. It has to be 3, 3, 4. Now another way of counting is counting starting from the left. And if we do that, that's going to give us 4, 5, 5. The rule is to go with the lower set of number. So therefore, we're going to go with 3, 3, 4. Now, because we have 3 groups of methyl, we need to indicate that we have 3. The prefix for 3 is tri. So we're going to place tri in front of methyl, and we're almost there. The longest chain is 7 carbons, so 7 is HEPT. And because this is an alkane, we add an ANE, that becomes a heptane. Final answer is 3,3,4 trimethyl heptane. This next question is a question on isomerism. The definition for isomers is that they are compounds that has the same formula but a different arrangement of the atom in the molecule. So the option that fits this definition is going to be the last one. This last question is slightly challenging because we need to know what makes a cis and trans isomer. To determine if an alkene is a cis or a trans, we look at the 2 carbons that are connected through a double bond. Each of the carbon has 2 groups attached to it. So they have fluorine in common and hydrogen in common. So if we look at fluorine or hydrogen, both of them are on the same side, and that makes them a cis. If the 2 groups are on the opposing side, like this, that makes them a trans. That's basically how we look at cis and trans. So the requirement for us to have a cis or a trans isomer is that we need to have 2 different groups attached to that same carbon. Just like what we have in our cis and trans, each of the carbon has a fluorine and a hydrogen. This is just an example. It can be anything as long as it's 2 different groups. So the requirement for us to have cis or trans, again, is to have 2 different groups connected to that same carbon. So we look at A, it's impossible for us to have a cis and trans because on each of the carbon, we have 2 of the same groups which are hydrogen. And then for B, it's impossible to have cis and trans because the carbon on the right-hand side has 2 of the same group which are hydrogen. So that makes it impossible to have cis or trans. For C, it's the carbon on the left-hand side that has 2 of the same group. So that makes it impossible to have a cis or a trans isomer. For D, each of those carbon in that double bond has 2 different groups, which means we can have a cis, which is drawn right here, and we can also have a trans. Basically, D is the right answer. But let's just go through E just to confirm. So if you look at E, that C double bond on the left, that has 2 of the same group. So it's impossible for it to have a cis and trans isomer. So the right answer is D. Here are the 13 functional groups that you need to know when figuring out which class of organic compound you're dealing with. So how many questions did you get right out of the 10? Check out this playlist if you need to review or try out another chemistry practice questions.